Hello and welcome to um, a video lesson on graphing tangent and cotangent waves. So we've talked about graphing secant and cosecant, and you use sine and cosine to actually graph those. Tangent and cotangent are very much related, like how secant and cosecant are. One is a reflection and a phase shift of the other, and vice versa. But you'll see what I mean when we actually do it, or when we go into Desmos. But what's important to know is what the parent function first looks like. So first we're going to talk about tangent. Well, let's write the equation y is equal to tangent of x. This is the parent function. And all of tangent waves will look something like this. There are a few components that are very, very important to it. First one is, and depending on how you graph it, I'm going to teach you how to graph it from its center. Or in other words, we're going to go from asymptote to asymptote. So when we start with graphing a tangent wave, we start at its center. This is important because unlike how we graph sine and cosine, if we had this is in pink, don't copy this down. If we have a sine wave, we are starting at the farthest left point. We graph its maximum, then midline, then minimum, then it is midline again, and we go from left to right. So we start at the farthest left point, and then we go 4 more points from there. Okay. Tangent, on the other hand, will start at its center point, and we have to go 2 to the left and 2 to the right. So we are starting at its center point. And a tangent wave will typically kind of look like this. It'll go up from left to right. Okay, that is one of our main components to this, and you will see what I mean because you could see here in a Desmos wave, here's a tangent wave. We could see that the wave repeats itself over and over, and it looks like we have vertical asymptotes at negative pi over 2, at pi over 2, at 3 pi over 2, and at 5 pi over 2. And if you notice, each wave repeats at, if you find the difference between pi over 2 and 3 pi over 2, it's exactly pi. So a tangent wave actually goes pi, has a length of pi. So a couple of components here. It starts at its center, and that center is 0, 0, if, and this should be a capital, if there is no phase shift, or, I'm going to put this in quotes, midline shift, or just write midline. Midline shift. I'm putting midline in quotes because it is no longer a midline. Because if you have a graph that looks like this point is not a midline. This is not the middle of it, because what's the middle between positive infinity and negative infinity? Well, you can't tell me because there is no midline for that. So I'm putting a midline in quotes. We still use that D value when we talk about a tangent wave. It's still some kind of shift vertically or horizontally, but it's not a midline anymore. Okay? Second thing we need to know is that, well, I probably should have had this up here before. Y is equal to A times, in this case, it's tangent. And I probably shouldn't just do A tangent, B x minus C plus D. So this is our midline shift, okay? The A value and the B value are stretching it and compressing it vertically and horizontally. So in this particular case, it stretches or compresses vertically and horizontally from its center. Okay, what this means is whether it's a change in your B value, well, the A value is a vertical stretch or compress, as is the B value for horizontal. And it is affecting the period. Horizontal stretch or compress. Okay? Third thing we need to know is that if there's no reflection, and put if in quote or underline, if there's no reflection, then the wave goes up from left to right. From left to right. Okay? And last but not least, this is probably the most important. It is a big difference between sine and cosine. Sine and tangent, and cosine and tangent. The period equation is instead of 2 pi over b, it is, so I'm going to just write this out. Instead of 2 pi over b, it is actually just pi over b. It is a big difference between the two, and this also goes for cotangent. So this is for tangent and cotangent only. Okay, so the period is pi over b instead of 2 pi over b. So let's graph a tangent wave. So if this is our case, we could still evaluate what would eventually be our fake midline, because it's not a midline anymore. It is a vertical shift. In this case, there's no d value here, so this is 0. If you want to put y is equal to 0, even though it's not an equation anymore. Amplitude in this case is 1, but this is a fake amplitude because it's not really telling you where the max and min are, because there is no max and min. We'll talk about that later. Reflection is still true. And for the sake of, let's see what happens later. Max is in quotes because it's not really a maximum. This is going to be 0 plus 1 is 1. The minimum is a fake minimum, which is a -1. There's no phase shift. And period is equal to pi over b, which is pi over 1, which is pi. Interval length is still the same, divided by 4, because we want 4 sections of it, so it's pi over 4. But this is the important thing. And I probably should have done this start at its center if there's no phase shift. We actually need to go 2 to the left and 2 to the right. So we graph starting at its center. So I would definitely make this little subnote. We need to go 2 intervals left and right of center to graph. Okay, so this is what we're going to do. We're going to draw, instead of drawing the farthest, the y-axis and then just graphing to the right of it, we're actually going to stretch it so that it kind of looks like a true X or a cross, or like a true XY plane. Okay, so in this particular case, there is no midline, it's 0, our fake midline. So and there's no phase shift. Okay, so we're starting at 0, 0. That is our center. We need to go 2 units to the right and 2 units to the left because we have the center for a tangent wave. This is only for tangent. Okay, so I'm going to do 2 units to the right and 2 units to the left. This will, and then we use the interval length in this particular case. 2 to the right using the interval length, so it'd be pi over 4. Pi over 4 plus pi over 4 is pi over 2. And then we would do the same in the left direction. Negative pi over 4, negative pi over 2. Now, a tangent wave should always start and end with an asymptote. Okay? And if you notice, when we did this before on Desmos, we have a tangent, or we have vertical asymptotes at negative pi over 2 and pi over 2. The same thing happens here. We have a vertical asymptote right about here. So let me change this so it's a dotted line. Right about here, we'll have a vertical asymptote, and we'll have another one right here. Okay? And this is where, so right now we have 3 critical points. We have the asymptote, which counts. We have the center, and we have the ending asymptote. We need 2 more. And this is where this is important. If there's no reflection, which this doesn't have, it goes up from left to right. So that means our graph should look something like this. But we need to actually plot points, and that's where our y-axis kicks in. We need a 1 and a -1 for our fake max and min. That's where these kick in, okay? Since it goes up from left to right, we are going to hit the minimum first and then hit the maximum. So negative pi over 4, comma, -1, that's a point, and pi over 4, comma, 1. And this is what the tangent wave should read. Okay, and we could always draw more tangent waves. All we have to do is go more points to the right. So if I continue to add intervals, the pi over 4, then we would have 3 pi over 4. We would have pi. We would have 5 pi over 4. And then we would have 6 pi over 4, which becomes 3 pi over 2. And then we would have another vertical asymptote there. Okay. We would plot more points. This is our center of this new tangent wave. We have 2 units to the right, left and to the right, and it goes up from left to right. So at 3 pi over 4, it would hit -1. At 5 pi over 4, it would hit 1, and we would have another tangent wave. Now, if I asked you to graph 2 waves, this is what it would look like. We're probably only going to ask you to graph 1, so I'm okay if you just graph this one. But this is what the parent function looks like. Okay? Now, a cotangent wave will look like this. Well, actually, let's go back to this. If I show a reflection for this, I'm going to drop in a negative, our wave changes. It's now going down from left to right. Okay? And why this is important is because, well, a cotangent wave naturally goes down from left to right. Except, if you notice, I'm going to highlight this one again and actually show it. They're not on top of each other. In other words, they're not the exact same thing. If I have a reflected tangent wave and a cotangent wave, they're actually different because one of them is phase shifted to the other. Okay? So, in a cotangent wave, we could actually start on the y-axis and just graph to the right. That's a nice part about cotangent waves. So if we were to graph, for instance, y is equal to cotangent of x, we would follow most of these procedures, except we are not starting at the center anymore. We are starting on the y-axis. So 1. Start on y-axis. I'm going to put this like sine or cosine. If no phase shift. Okay. Step 2. Rule still applies, stretches and compresses horizontally, vertically from for the A and the B value. So same as above. Step 3. If no reflection, it goes down from left to right. Okay. And then step 4. And sorry, I should have added this and start on the y-axis if there's no phase shift and graph to the right. Four to the right. What I mean by 4, I mean by 4 points, 4 using the interval, just like sine and cosine. That's why I wrote like sine and cosine. And 4, same as above. Okay, so cotangent. We would follow the same procedures. Once again, this is not a midline. So I'm going to put that in quotes. Midline is 0 here, or y is equal to 0. Amplitude, fake amplitude, is 1. Reflection, that's true, none. Fake max is 1. Fake minimum is -1. Phase shift, none. Period is pi over 1, which is just pi. And then interval length is pi over 4. So just like sine and cosine, I'm going to graph the y-axis first and then draw some points to the right. It is predominantly going to be to the right. I'm going to draw my y-axis as 1 and -1. I'm going to draw 4 points to the right, just like we do with sine or a cosine wave. And we're using the interval of pi over 4. So this is pi over 4, pi over 2, 3 pi over 4, and then pi. Now, just like how tangent is, we always start and end with an asymptote. So we are starting with an asymptote. And I should probably put this here, start on the y-axis with an asymptote. Okay, so we should also end on an asymptote. Okay, and then now we could graph our critical points. So those are 2 of them. It starts and ends with an asymptote, just like tangent. And then our first one is the center. Center is where that midline is, our fake midline at 0. And then we need to go down from left to right. So going down from left to right means we should have something that kind of looks like this, just like it did on Desmos. And that's where these fake maxes and mins come in. Going down from left to right means we hit our fake max first at pi over 4. It is going to be 1. And then we hit our minimum at 3 pi over 4, which is -1. And we hit our fake max and our fake minimum. Now, if we wanted to graph another wave, we would have to have some more. 1, 2, extend this out. 3, 4, starts and ends on an asymptote. So we should know there's one there as well. Excuse me. And then we should have 5 pi over 4. 6 pi over 4, which is 3 pi over 2. 7 pi over 4. And then 2 pi. 8 pi over 4. And then it would repeat the same pattern. Hit the fake max, hit the fake midline, hit the fake minimum, down from left to right. And let's try that again. Okay, so that is how we would graph the parent functions for tangent and cotangent. Tangent goes up from left to right, cotangent goes down from left to right. Another important feature, we always start and end with an asymptote for both of them, but tangent is a special one. Tangent, we start from its center and then we graph to the left and to the right of it. Okay, so let's do 2 quick examples of this and then we'll call it a day. So 2 additional ones. So this is our foundation for it, our parent functions. If I, for instance, give you y is equal to, let's say 2 tangent, and let's say we have pi over 2 x plus 1. Okay, so right now, for sure, actually, let's drop the plus 1. Let's leave it as 2 tangent pi over 2x plus nothing. So, for sure, I'm going to do our fake midline 0. Our fake amplitude 2, because it's still the a value. Reflection, none. Max, fake max anyway, because it's not really max. I forgot to explain why. I'll explain it in this one. Our fake max is 2. Our fake minimum, it's still the same process, is -2. Our phase shift is none. Our period is pi over 2, which is pi times 2 over pi, which cancels out. So our period is just 2. Our interval length is going to be 2 divided by 4, which is 1/2. All right. And as a tangent wave, we start at the center if there's no phase shift. We always start at the center. If there's no phase shift, which there isn't, and no midline shift, then we are starting at the origin. So in this particular case, we are starting at the origin. Okay, our fake midline, if you will. We need to go 2 units to the left and 2 units to the right because this is specifically a tangent wave. So we start at center, which means we have to go to the left and 2 to the right. Since our period, our interval length is 1/2, 1/2 plus 1/2 is 1, negative 1/2 plus or minus of 1/2, negative 1, and that will indicate we have asymptotes there at negative 1 and 1. And we clearly see that the distance from negative 1 to 1 is 2, okay, which is our period length. Now, tangent wave goes up from left to right. So that means we'll hit the our fake minimum first. We should actually also mark these y-axis. 1 and 2, negative 1, negative 2. In graphing this, we hit our fake minimum first. So our fake minimum would be at negative 1/2, comma negative 2, and then 1/2, comma 2. Here's what our tangent wave will look like. And there we have it. Okay, we always start at a tangent wave. We always start at the center, go 2 to the left and 2 to the right. All right. If there was, for instance, a phase shift, or let's say even a vertical shift, if this was a +1, we would take this entire graph and it would just shift up 1 unit. Okay, the center would now be at 0, 1. Or if there was a phase shift, we would take the entire graph, including the asymptote. So let's show this. If there was let's say there was a phase shift to the right, by 1 unit, then it would shift this way. Okay. All right. So let's do one more. Let's do a tangent or a cotangent wave. Let's pretend we are going to graph y is equal to. Let's do no amplitude this time. We'll just say cotangent. Let's do one actually. Let's say this is 3 cotangent. Let's say we're going to do 1/4 x minus 1. Okay, so cotangent wave. Cotangent wave starts on y-axis. And then we go to the right. So we graph 4 points just like a sine wave. So let's do this. Midline, our fake midline. Y is equal to negative 1. Is our fake amplitude? It's going to be 3. Our reflection, none. By the way, if there is a reflection for a cotangent, it will go up from left to right as opposed to down. Our fake max and our fake minimum will be 2 and negative 4. Phase shift, none. Our period is going to be pi divided by 1/4, which is the same as pi times 4 over 1, which is 4 pi. Then we have the interval length. 4 pi divided by 4 is just pi. And now we could graph. Tangent always starts on the y-axis if there's no midline shift if there's no phase shift. In this case, there is a midline shift or a vertical shift at -1, so we're definitely going to need that. We're going to need a maximum of 2 and the minimum of a fake minimum of -4. So we also need 4 points to the right of that first point. So since our interval length is pi, the first one's going to be pi. Pi plus pi is 2 pi, plus pi is 3 pi, plus pi is 4 pi. And tangent wave and a cotangent wave should always start and end with an asymptote. We start with the asymptote for cotangent, which is nice, at 0 pi and 4 pi. Now, this midline shift, this fake midline shift is at -1. So that means at 2 pi, it's going to be centered here at -1. Okay? We also know that it is a tangent wave without a reflection, or cotangent wave without a reflection. So that means we're going down from left to right, which means we hit the fake maximum first. And the reason we call this a fake, well, let me finish graphing this first. And then we have one at 3 pi, comma, -4. And here we have, ooh, that's terrible. All right. And the reason we would call this a fake maximum is because this is not really a maximum. It is not even close, because if this graph goes on infinitely up, which means our maximum in reality is infinity. This is not even close to that. So we just use this fake amplitude to calculate another critical point. Okay, pi over pi, comma, and then using that fake maximum helps us find a new point, pi, comma, 2. Same thing goes for here. The fake minimum is 3 pi, comma, -4. And this is not really minimum. Just like how this amplitude is not really an amplitude because it doesn't help calculate the maximum or minimum. It's a vertical stretch. But we use it just to find new points to actually graph. Okay? All right. So that is how you would graph tangent and cotangent. Definitely know what these look like, the parent functions. Definitely know that this is pi over b instead of 2 pi over b, and that we always start and end with an asymptote. Okay? Specifically, tangent starts at its center, and we need to go 2 to the left and 2 to the right. But that's all I have for you today. Try out that homework, and I will see you in the next one. Bye.